Hello dear students, we were discussing about module 5, that is geosynthetics and reinforced construction. So in that we have last part some miscellaneous methods of ground improvement. First we will discuss about stone columns. Stone columns are nothing but the vertically filled with the compacted gravel to form a column like structure in soft soil, especially in soft soil to improve the overall strength of the loose and soft soils. We are going to construct the stone columns. Stone columns refer to a columns of compacted gravel sized stone particle constructed vertically in the ground to improve the performance of soft or loose soils. The stone can be compacted with impact methods such as with falling weight or an impact compactor or with a vibrofloat. So the different methods of compaction energy can be given to the aggregates, either the falling weight or impact compactor or with a vibrofloat method. So vibrofloat method, which can be easily used by giving vibrations, the hole can be formed, which can be refilled with the aggregates, then it can be compacted. The method is to increase the bearing capacity, overall strength, which I told, up to 240 to 480 kPa we can increase, reduce foundation settlements, improve slope stability, reduce seismic effect, reduce lateral spreading and liquefaction potential, also permit the construction on loose or soft fields and pre-collapse skin holes prior to construction in cuts regions. So especially to the overall improvement of the very loose or soft soils, we are using more and more the stone column. So this is showing construction method or the steps involved in the construction of a stone column. So in first we have, there is a some so vibratory probe or the hole can be formed initially, then we are filling with the aggregate, then the compacted energy can be given to the aggregate to form a rigid so structure. So this is the second step, filling the next layer, then this is the final finished stone column. So also we have some vibratory method to form the stone columns, especially in loose soils. So by giving vibration energy, which can be modified to dense form, so that there is a diffraction will be created. It can be backfilled with the aggregate, then it can be compacted. So then next layer, finally finished products. Those stone columns are very economical to construct, also very easy to construct. So these are very much we are using nowadays in soft soils. Next we have crib walls. Crib walls are nothing but a concrete structure or a precast concrete structures which can be used as a crib walls. So concrete crib walls are gravity retaining walls constructed from interlocking precast concrete components. So these are precast concrete components. By interlocking we can construct a small retaining structures. They can be used almost anywhere where a retaining wall is needed, including driveways, building sites and garden areas. Anywhere we are requiring a retaining structure, we can go for crib walls. So this is a photo showing crib walls. Whenever we needed a retaining wall, so instead of that, so crib walls can be used economically and efficiently. Then we have Gabion walls, which are very much economical one, flexible one to retain the slope structure, especially for the erosion control of offshore structure or the stability of the slope. We are using Gabion walls. So Gabion wall is a welded wire cage or box filled with materials such as stone, concrete, sand or soil. So Gabion is nothing but it is a welded wire mesh, that is a box shape, or maybe flexible material also we can use, so which is filled with the mostly we are using stone or rock material. We can also use concrete, sand, or soil. Gabion is a partially flexible block construction used for slope stability and erosion protection in construction. Various types of gabions are constructed and used in different engineering construction. This is one of the example which I already discussed. Use of stone-filled rope net gabions for shoreline stabilization at Swami Narayan temple, Tithal, Gujarat. So the temple, okay, very near to the offshore environment. So the erosion as proceeds, so the temple may get damaged. So to avoid that, for the protection of offshore, so Gabion wall has been used. So this is one of the Gabion structure wall which has been used efficiently for the slope stabilization. So you can see the construction is very easy, not required the highly skilled labors. So just okay, so spreading of the cage or gabion, then filling the stones aggregates there. Okay, then we have mattresses, which are also known as live brush mats or brush matting. A brush mattress is a combination of live stakes, live branch cuttings installed to cover and stabilize the stream banks. So especially to stabilize the stream banks to control the erosion or erodibility of the water, we are using these mattresses. So this figure shows the mattresses spreading up for the livestock there, so that it will okay stabilize the banks of the stream there. Then we have anchors. So anchors are very much we are using to stabilize the slope protection or slopes. Anchors are tendons which are placed in competent rock or soil to control the displacements and provide vertical and lateral support for engineered structures and natural slopes. So especially to control the displacement or the movement of some rock or the slope section. The primary function of the rock anchors is to modify the normal and shear forces acting on the sliding planes. Ground anchors are used for tensile stresses, especially the ground anchors which are used to hold the tensile stress. They transmit the forces from a structure, that may be wall or foundation, to the ground in which they are anchored. So this figure shows the first one. You can see this is the polyester resin rock anchor system. So this is second figure, the rock or earth anchors. You can see this is the natural slope, natural ground which has been present. So this is the extra fill has been placed to make it as horizontal to hold this the sliding mass. So this is a sheet file has been given. So this is the anchor which has been provided, okay, to hold this fill or to hold the structure, to overall structure. So this type of ground anchors we can use efficiently in the field. So this is also one of the rock bolt or the anchor has been shown. So this is the weathered fractured rock structure is there. So natural sandy soil, above there we have some fill material. So to hold this together to stabilize overall structure, we are using okay anchors there. So this is the advantage of anchors there. Then we have micropiles. A micropile is a small diameter drilled and grouted displacement pile that is typically reinforced. Okay, so micropile is nothing but so very small diameter, okay, piled which is having less than 300 mm. So we know that what is meant by pile. So pile foundations also we call, okay, so the diameter is very less but lengthwise it is much higher. So the diameter also here we are using less than 300 mm. So those we call it as the micro piles. Okay, so a micropiles is constructed by drilling a borehole, then placing the reinforcement and then grouting the hole. So micropile construction, so it is usually we use for, okay, so to control the displacement or displacement of foundation structures. So micropiles can withstand axial as well as lateral loads. So in first figure you can see the micropiles has been used as a foundation support structure. So this is an abutment constructed to support a bridge. Okay, so this is the foundation of that abutment. So to avoid any displacement or to support your foundation, so we can construct the micropiles. These are the micropiles there. So second figure for the slope stability, so this is the possible failure of the failure plane of the slope. Okay, so to stabilize this, these micropiles has been used. Okay, so this is also the anchorage system between the sliding and the passive soil mass. Then we have soil nailing, which is very much we are using nowadays to stabilize the existing ground, existing slope. So soil nailing consists of a passive reinforcement of existing ground by installing closely spaced steel bars. So this is the nails are the bars which has been installed in a existing ground structure. So soil nailing is nothing but it is inclusion of the passive reinforcement. These are the reinforcement, passive reinforcement. Why we call it as passive? So as you install or insert the soil nails, there is a passive displacement of the soil so that it becomes dense there. So closely spaced steel bars are nails, which we call as nails also, which may be subsequently encased in grout. As construction proceeds from top to bottom, shotcrete or concrete is also applied on the excavation phase to provide continuity. So the construction of soil nailing, it will start from top and end at the bottom. So consider here there is one slope is there like this. Okay, so initially what we do, we will cut this about 1.5 to 2 meter slope, then we will insert the nails. Okay, so bolting system is also there. Then we can provide a shotcrete or a concrete. Okay, so will be sprayed on the excavated ground. Then you can provide some facing elements. Okay, so then again next layer will be excavated, then again the soil nailing installation will be done, then again next. So this is how we construct the soil nailing constructions. So in a soil nailed retaining wall, the properties of and material behavior of three components plays very important role. So first is the native soil. So we cannot do or apply soil nailing technique for all types of the soils. Okay, so for very soft soil or the soil which is having the rock or boulders, large size boulders, we cannot use this type of technique. So the three components which plays very important role, that is first one is the native soil or the in situ soil which we are, okay, stabilizing, which plays very important role. Second one is the reinforcement. Okay, so the nails are reinforcement which you are using, also the strength of that nail is also plays very important role. So we have to take care against erosion control or to provide a proper strength reinforcement. Then we have facing element. Okay, so finally we are providing a facing element, okay, which is also plays very important role. Facing is provided to hold the reinforcement in the soil properly, also to provide the aesthetic appearance. Okay, so which plays very, these three plays very important role in the performance of the overall structure. So some advantages of soil nailing we have: requires smaller right of way, then construction is less disruptive to the traffic. So whenever you're constructing or to stabilize a existing slope which is very near to the road system or traffic, okay, so which requires a less disrupt or which occupies the less right of way, then causes less environmental impact, then relatively fast in construction and uses typically less construction materials and hence economical, so which is very economical one. So the very less equipment are needed, very less materials are needed, so not a very heavy structure, heavy machineries are needed for the construction of soil healing technology. Then limitations we have: so whenever in the existing slope which we want to stabilize, there may be presence of some, okay, so utilities like underground structures like pipeline connection or sewage structures, so it can restrict the place of the or placing of or inclination and length of the soil nails. So this is one of the disadvantage we have. Then whenever there is a groundwater very near to the ground level, so we cannot apply this condition, because whenever you start constructing there may be seepage of water, may be disturbance to the construction. So the soil nail walls are not well suited where large amounts of groundwater seeps into the excavation because of the requirement to maintain temporary unsupported excavation phase. So while before the installation, so when you excavate the material, so you have to make this sure that, so this should be unsupported until you install and provide the facing element. So whenever the groundwater is very high level, we cannot apply this type of construction of soil nail walls requires specialized and experienced contractor. So we cannot use any contractor, so a specialized one which is expert in soil nailing construction, which is having equipments of soil nailing installation, we have to go for that. That is also that. So this figure shows the application of the soil nailing technology. So especially we use whenever there is a traffic is moving, whenever there is a possibility of failure of the slope, okay, existing slope, to stabilize the existing slope, we are going to use this type of soil nailing technology, which is very useful nowadays. Thank you.